Okay. No referral has been posted twice. For some reason, the geometry tends to get posted a lot faster than, like, the not geo. I've never figured out why. Hold a new ready. Ah, no one gets Duncan. Okay then. Ah, no! I did not mean to do that. I somehow managed to auto-complete the command kill all Firefox. USEMO 5 is definitely going on medium-sized NT. Yes, I agree. Okay. Man, Holden is so popular these days. Oh my gosh. How do I make this window bigger? Okay. So why is this font size so freaking big? Man. I swear, everything is just like a mess. Like I logged in and then I couldn't access the problem database because the key had expired from me not using it for so long. So yeah, we're fixing a lot of stuff live. Okay, let's reveal the authors. Nice. Oh right, I also managed to kill pretzel rocks by accident, so I need to redo that. All of them were so hard. Yeah. Day one was pretty rough. Alright. This is USEMO 4, USEMO 5. I hope I put the accent in the right place. Okay, and I think the tradition is here. I'm supposed to write like yours truly, right? Is 2008 G3 trivial by 2022 for? Maybe? I don't remember what 2008 G3 is off my head. What is 2008 G3? Oh, I don't even have that in my database. Wow, okay. Yeah, problem 6 is mine. It's like I've had that problem in my bank for like 5 years. And never submitted it anywhere because I was like, I don't feel like this problem fits that well anywhere. And then this USEMO happened where like I literally just like died on problem submissions because everyone was submitting to TST and USEMO, and I was like, well, all right, I guess we need a hard algebra problem, and then that happened. So. Yeah, it has 2012 8.1 vibes. Also, I forget what There was another one, that linear algebra functional equation from like problems from the book. It also has that feeling, I think. Because we'll also do a. Do you guys keep a running shortlist? For USEMO, no. For USEMO, TST, and USEMO, the problem proposal procedure starts fresh every time. Like for every cycle, everyone sends in problems. Some of them are selected and the others are returned. The one that doesn't do this is the IMO because they have the IMO shortlist. Predicted modes. If I had to pick numbers now, 15, 25, 35, but I'm very not confident in those numbers. And we'll probably change my mind. I will almost certainly have different numbers by the time grading is done. Yeah, that one. Yeah, Gabriel Dos Penescu's one. Okay, day one. Man, like, okay, I'm gonna say like, I'm gonna say like 25, 25, 40. 40 might be a bit low for the 3 actually, because I don't think many people know how to do that. There's like a length-based solution where you look at like just the distance from P to each of those things and use a form of Ptolemy, but I don't think many people know about it. That was for day 1, 25. That was day 1. I had like 20-ish for problem 1 at first, and then a lot of people told me they didn't solve it, so I went up. Problem 3 I think is hard for me to judge because like if your style is like pure synthetic, it's actually pretty hard. And if you are more naturally inclined to lengths, then doing the Ptolemy thing is pretty reasonable. Like I would not have gotten USEMO 3 because I like the reasonable solution is just like not my style of. I'm so bad at trig, I guess is the short version. Like I never got the hang of trig because like the thing with trig is that it's hard to show that 2 quantities are equal compared to like in complex everything you get is a like rational function or polynomial, like a quotient of 2 polynomials. And so if they're equal, then they're just equal and you can see it coefficient by coefficient or by factor. But with trig expressions, you can have 2 trig expressions that don't look the same but are equal, and there isn't like a good deterministic way to verify it other than like going with the full e to the it plus e to the minus it and doing a horrendous amount of expansion. Is the Ptolemy like sine theta 1? So let me check. Wait. Huh? I think it's like, oh, it's on the handout. Okay, well, yeah, then it's that. That also means I have a typo, because in my setup it's, oh crap. Okay, that's not good for me actually. Oh, I need to fix that. Was problem 6 meant to be bashed? It depends on what you mean by bashed, but there's no trick if that's what you're asking. Like, you do actually have to compute like the first 5 or 6 things, as far as I know. Just because the answer set is so pathological. Yeah, that's basically what you do. Although what you wrote there looks horrible. You can make it cleaner. Oh god. Alright, how did I screw this up? Wait, are you sure it's division? Like, in my notes it's sine theta 1 times pp1. Is the construction? Yes. Yeah, if you have the full answer for problem 6, like, if you have the full construction set for 6, that's definitely worth probably quite a bit, actually. I thought division for cyclic. Am I crazy? Because I'm like reading a proof that gets multiplication, but oh, did I flip the order? Okay, cool. Yeah, I think if you change all the division signs, the multiplication signs, that's actually this statement. Oh my god. I mean, okay, that's not that bad. Okay, I guess I should... I guess I'll present, because people are starting to talk about the solutions. So... Didn't bother. Okay, well, if that's... yeah, I guess that's... So we're gonna give the author's original solution. There's some variants of it based on, say, the intersection of the... based on different intersection points, but whatever. Well, this one with this one. So the big thing about this problem is that it really is 2 parts. Like, what's going to happen is that the 2 things you want to show are actually parallel to the internal and external angle bisectors. So what I'm going to say is let u equals AD cap BC and v equals AB cap CD, which actually is why I specified in the problem statement that the opposite sides weren't parallel. The problem statement still works, but you have to do an extra case and it was annoying, so I just cut that out. You're welcome. Okay, so then what happens? So angle condition rewrites as saying directed angle USB is a directed CSB, i.e. UQ squared equals, sorry, not UQ, US squared equals UB times UC. So basically the angle condition turns out to say exactly that like US is tangent to the circumcircle of SBC. There's a harmonic solution? Jeez, I gotta see that. Also, for similar reasons, is equal to UQ squared. So already we get that US is equal to UQ, which promises that line SQ is perpendicular to the angle U bisector. And then, of course, similarly for QS. Meanwhile, in order to control line XY, what we will do is say SXQY is the kite that everyone keeps talking about. And it's basically more angle chasing. So you chase all the angles, and then stuff happens, and then you get the thing you want, which is great. And also, finally, angle U bisector is perpendicular to angle V bisector. And then that's it. Had to, yeah. Angle chasing, I was surprised at how long the angle chasing was. Like, normally if there's this little setup, I expect the angle chase to, like, just work. But, but you actually have to write out quite a few things to get the angle chase to complete. Yeah, and everyone that says they try to show it's a kite, there is indeed more than one solution. Everyone that says that they thought that it was a kite, that's the kind of thing you're supposed to write down and pray for partial. So, hope you wrote it down. If not, now you know. Okay, let's go on to 5. I think that's the one people are most curious about, actually. Yeah, yes, ABEXDCEY is the other official solution that's written right now. Okay, I'll mention briefly that that is a thing that can happen. So, alternate path. So if E equals AC intersect BD, then E lies on XY by Pappus theorem, and this point E is the one that you use as the crux instead of U and V. So the other solution that I have right now does not construct the point E, or U and V, and constructs the intersection of the diagonals instead, which lies on XY by Pappus theorem, and as 3VT is saying, ABEX and DCEY are oppositely similar. Is Pappus worth a point? Probably? I actually need to check what that rubric looks like right now. I have it on. I am behind on developing rubrics. Or, yeah. Correct, yeah, answer to problem 1 will probably be worth a point. Enos proposers, proposers are that set. I guess I'll edit them into ALs since the problems are probably up by now. Do I have a hotkey for hiding my key camera? I don't remember. One deleted edge. Maybe. Probably, honestly. Okay, so... Oh god, did it actually get posted twice? Ugh. Oh no. What do I do? Global with respective vertices? Isn't that the official solution? Oh, we're just gonna do this. There's already another thread. Okay, cool. And divisors. Right, I was gonna edit in the authors. So, okay, that one's in already. Freak! I don't have the accent on. This isn't LaTeX. Ah! Accents. Oh my lord. I need to get an ad blocker on this. Okay, here, found it. No. Ah, close enough, I'll take it. Success! International keyboard. How does that work? Like, do those actually just have more keys, or like, is it on a software level? Actually, the others don't have proposed by, so I'm gonna make this consistent. Wait, is that true? Wait, let me verify that before I. Yeah. I forgot whether I like put the text proposed by or just name. I think this year I put just the name. I'm not consistent from year to year, I think also. Alright. Let's do problem 5. Why is USEMO? Thanks for the sub. Yeah, I don't know. Math is just... it's math. There's nothing you can do about it. Alright, so first of all, I would like to say thanks to Nikolai for giving me a definition of have limit infinity that actually fits in like one sentence. Because I was about to do this stupid thing of like, for every constant c there exists n such that an is greater than c or whatever. Or no, for every c there exists like m such that for all n, you know, the ugly thing. And then it turns out there's this much cuter way of phrasing it that is only one sentence, even though it's completely unintuitive. So thanks to Nikolai for that. As well as a lot of other things. Like Nikolai carried the development of this contest really hard. Right, okay, where was I? How do you do this again? So very roughly what's going to happen is we're going to try to shoot for some sort of size contradiction by making tau of p of n divisible by a large prime. So, of course, there's immediately some complications called I hate small primes. So we're going to do the following. We're going to define the constant little c to be the GCD of all the stuff. So I'm just going to assume that p is like monic and not constant. Sorry, not monic. Positive leading coefficient and not constant, because otherwise the conclusion just never holds. Yeah, shout out Nikolai. Does saying no polynomials exist? No. Sorry, the answer is not what their point here. Okay, so here's what I'm going to do. I want to claim that for every integer n, at least 2, there exists an R of n which is such that two things. I want two things to be true. One is that VP of P of R should agree with VP of C for every prime which is at most n. So I'm gonna edit that in my notes. So I wanted to have the same VPs as the GCD of everything. And moreover, I want R to be R equals Rn. Should not be too big, but also not too small. So I'm going to say exactly how big in a moment, but we're just gonna, can you take C equals P1 instead of the GCD of all of them? Let me see. I think so. I think you're right. Probably C equals P1 is sufficient. Okay. Why can't P? Oh. Yeah. Okay. Just P of something. some positive thing. Okay, great. So because I haven't told you how big is big, we will not put a proof in, or at least I'll start the proof, but I don't want to do this. I will start the proof, which is called to ensure the first bullet, use Chinese remainder theorem, get a unique R modulo, well, not necessarily unique, but in the sense that there might be multiple things. Get an R which is modulo the product of the prime powers that you took. So it's this giant product. P less than or equal to n, P to the VP, C plus 1. Okay. So that's like how is the first bullet with points. Unclear, like I don't actually know how you do that in isolation. I think it would be more likely to get points if you got to the thing I'm about to say, which is how to use that to get some sort of size information. If you just say that alone, I'm not sure what to... My feeling is that probably wouldn't be worth anything because it's not very... It doesn't... It's not specific to this problem. Like, this sort of thing has been done in many problems where it's just like, by Chinese remainder theorem, I will control the VP, which is just a thing you can do. I think you would actually want to extract some size information from it. Okay. Alright, so now here's what we're gonna do. So assume for contradiction that all AI are eventually larger than like C-ish. Why did I use... Yeah, why did I use GCD P1, P2? I should just use P of anything. Okay, I don't know what I was thinking. Because GCD is morally correct. Wait, so you're just saying, oh. Okay, but also, like, why don't you use the... What if C equals 0? So, what we're saying is replace C with any positive output of capital P. And this proof will still work. Because I don't know why we picked the GCD. I mean, it's true for the GCD as well, but we don't need to use a GCD. You're right. I think we will probably not deduct many points for the stupid 0 cases. Like you should be careful about this because like occasionally you'll be in like some country whose coordinators are really strict and they will deduct for stuff like this, but I will probably let it go. Okay, so let's roll with this. So pick an n such that... So pick some large n and consider... We're going to look at r equals r of n, alright? And... Cool. So... What happens is, because of the way this is rigged, there's going to be some prime, well, denoted by p sub n, which is larger than n, dividing pr and hence tau of pr. And the reason is, if there was no such prime, then p of r is too small. We're promised that the GCD exceeds c, so p of r exceeds c, but we have picked r such that the VPs are not enough if you only use primes that divide primes that are at most n. Yeah. So consequently, we got the large prime that we are going for. So that implies that p of r itself from the tau is divisible by qn to the pn minus 1 for some other prime qn. It's like, if you want tau to output a large prime, one of the exponents has to be pretty big. So, for some prime qn. And also qn greater than n. Because if qn is a small prime, then what happens? I wrote VP, but that is not... Oh, right. All the small primes have exponent that is less than VP of C, which is less than C, which is less than N. Or V of whatever C. Okay. P of n is sorry, let me write that out. We're dividing AR. Yeah, so it's like you take a big prime dividing a sub r. It has to exist because a sub r is wait, hang on. No, hang on. Wait, did I just do something stupid? No, it's a sub r. Right, a sub r is bigger than c. Okay, yeah. Yeah, a sub r is bigger than c, so a sub r divides p of r, so you get a... Okay. Yeah, this is a really stupid way to phrase it. Actually, I should just say it divides a sub r. P of r. Okay. Okay, so yeah, there's a... I should just say divides AR. And then as Pn divides tau of P of R. This, okay, yeah, blah, 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 blah. Okay, cool. Okay. Alright, so, yeah. Okay, so what we now have is P of R is divisible by Q to the P minus 1. So, Qn to the Pn minus 1, where both P and Q are bigger than N. So this is like more than N to the N. And that will... Now I want to go back and fill in how big do I want. So, you know, this is our modulus. It's this giant product of random stuff. So, I mean, actually that just tells us what the easiest thing that we can do size-wise is to pin it between this and R is less than... So if you have the giant modulus M, something like that. Okay, the reason we want R to not be too small is because you need A of R to actually satisfy the eventually large thing, right? Because if your claim always returns, for example, if you picked like C equals P of 1, and then your claim just always gave you R equals 1. That doesn't do you any good. So that's why we want some lower bound. We don't really care what lower bound as long as it increases N. But we want it to not be too big, and the reason we want it to not be too big is because I'm about to use it. So now, how can I estimate P of R? It's less than or equal to like, do I just use O? Yeah. It's less than or equal to the leading coefficient times like degree P of R. So this is some constant times, oh Jesus, we're just gonna round everything up. N to the degree P pi N, where pi of N is the number of primes less than or equal to N. So I'm just gonna throw away all the information and bound everything by N. That's good enough. So on the one hand, P of r is promised to be bigger than n to the n. On the other hand, it's promised to be at most degree p times like pi of n. And here's a fact that you probably know. Pi of n over n goes to 0 as n goes to infinity, i.e. the primes have density 0. So the right-hand side is smaller than n to any linear polynomial in n. So this gives a contradiction. Yeah. Yeah, it's such a good size problem. All right. Can we show tau of p of n? I'd have to see a proof. I'm not currently aware of a proof that tau of p of n grows sublinearly in n. Wait, no. Can you cite prime not? Yes. I don't care. Tau of p of n less than n goes the wrong way, right? You want to show that a of n does not have limit infinity. But just showing that, for example, if a of n grows like the size of square root n, it still goes to infinity. Yeah. If you were trying to cite prime number theorem in the form like n log n, it would probably still be okay, although you might worry like a tiny bit if like you have some very... Honestly, it should just... Prime number theorem should just always be okay to cite. Like, there's... Anyone who doesn't let you cite the prime number theorem, like... I don't know. At that point, it's the problem selection committee's fault. Like, people will know the prime number theorem. That's a really important theorem. Like, how many primes are there is about as fundamental as it gets. Like, yeah. But it's actually pretty easy to give an elementary proof that pi of n grows sublinearly in n. Because all you do is if you look at the proportion of primes that are killed by each prime p, it's 1 minus 1 over p, right? Like, for example, when p equals 2, it's saying that at least half the numbers are divisible by 2. And then when p equals 3, it's saying like, you know, a third of them are divisible by 3. And my Chinese remainder theorem, not 1 minus a half, silly. The proportion that you get will be 1 minus 1 over p times n plus an error term, which is little o of n, depending on like how the rounding turned out. And in fact, even more explicitly, if I pick a threshold, which I'll call capital B because apparently that's popular for thresholds, plus like B-ish. It's actually, I'll just write O of B even though I'm pretty sure it's exactly B or something smaller than it. Wait, no, that's not true. That's not O of B. What is it? O of B. Oh yeah, O of B, because you get at most error 1 from each prime, like with respect to rounding. Right? No, that might not be true actually. What's the error you get from... No, it should be at most... Okay, whatever. It doesn't matter. Anyways, this thing diverges because it's literally the harmonic series reciprocated. Yeah, so as p goes to infinity, you get every term of the harmonic series. 1 bit for each problem I can solve. There you go, at least one. And yeah, this goes... Okay, cool. Okay, yeah, I think C can be any positive thing. So I will update that in my set of notes. What's a good letter for like just like a fixed point? So C is good for a constant. I'll just use N0. I think that is clearly like... Yeah, and then everything just works the same. There's no changing to the rest of the solution. Five minutes of answering pulls randomly. Okay, let's do the FE. So I actually initially wanted to make it just like, let k be a positive integer, solve the functional equation in terms of k. But I was persuaded that this was like a little more... This gives you a hint that it's not just going to be linear solutions. I guess that's what I was trying to say. Yeah, so as everyone's saying, the answer is 139. So I'm actually going to solve the functional equation, not from z to z, but from z to like some field, like C or something. This will make my life easier because it turns out you just don't need the fact that the output is an integer. It's just never used. Yeah. So when k equals 1, the family of solutions is constant plus constant x mod 2 plus constant. When k equals 3, any x and x squared both work. And when k equals 9, x and x to the 4th both work. So to verify this dash, do I get points for k equals 3 and 9? Maybe? Okay, so now for the part where we show these are the only solutions. So because I'm going to say like for k greater than 1, f of 0 is obviously 0, and when k equals 1, I'll shift by a constant So without loss of generality, f0 equals 0. Also, for any k, since like shift by a multiple of the identity function, so that f of x is equal to f of minus x. So I'm going to rig it to be even. Oh crap. C minus. I was wondering. Sorry, I'm stupid. I meant f of 1 equals f of minus 1. I was like, how do you get even just from that? And okay, we will now show for that after these shifts, f is 0 unless k equals 139. F is identically 0, and then that will solve the problem. So how do you get f of 1 equals f of minus 1? You shift by a multiple of the identity. Or does that not work? That should just work, right? Oh, okay, yeah, okay. Oh, yeah, that's harder. Okay. So we're gonna start plugging random junk in. Basically, my goal is to get a recursion. Okay, actually, sorry, I'm gonna do one last shift. No, I'll do that later. So if I plug this in, what I'm really trying to do is that rig this thing. So you plug this in, and when you look at the latter two equations, it tells you that by induction, you conclude that f is even. Because it says like f of n plus 1 and f of minus of n plus 1 is related to n and minus n in the way that you want it to be. So you get f is even, and now this equation cleans up. There's no more negative terms, and we get f of 2n plus 1 plus f of n plus 1, or sorry, n plus 2 f of n minus 1 is equal to whatever the heck the left side was, I already forgot. Plus 1 plus f of n plus f of 1. Alright, cool. So put my actual birthday. What is research power? Okay, anyways. So that's one equation. The other is we're going to generate the equation f of 2n plus 2 of f of n, and 0. So what this is it's a recursion now. For every positive integer n, I can now compute f of n in terms of the smaller values, except like f0 and f1. Although f of 0 is 0, so it's just 0. So recursion, yay! Man, I forgot which. Okay, whatever. Smiling. Yay! Okay, so now we're going to pump this recursion. So f of 1. So I'm just going to scale so that f of 1 is 1. Technically, this is illegal because f of 1 might be 0, but if f of 1 is 0, then everything's 0, so like whatever. Well, let's say assume for contradiction f of 1 equals 1 or something. Okay, so we're going to grind out like a 7 terms? So f of 3 is like k squared. So the way you debug your work while you're doing this is you plug in k equals 3 and k equals 9 and verify that it matches the thing that you expected. Because you can see like f of 2 really is equal to 4 and 16 respectively at k equals 3, 9. K squared, 3 and 9 give you so on. So this is how you debug to make sure that you haven't messed up the recursion anywhere. Because so far we haven't, everything we've written works equally well for any k. Actually, we're never going to use the value of k, really. So blah. 2k cubed. Okay, and then lo and behold, 8k cubed minus 2k squared plus 24k minus 8 is the... Actually, I might need f of 8 after all. I thought I only needed up to 7, but I think I need 8. Okay, so when does this end? The answer is that at any point I can plug in like a different triple ABC that gives me, and unless it's one of the ones that have been implicitly used, it's going to give me some relation. I don't know what that relation will look like, but it'll be something. And so that's what we're going to do. I'm going to... the first thing that we haven't used turns out to be 5 minus 3 minus 2. And when you plug that in and expand, you get... I don't want to write this out. I'm just going to say what it comes out to. You get a quartic polynomial. Isn't 6k... Yeah, what did I type? Oh, yes. Oh, crap. The copy pasta is strong. What am I... Wait, this is completely wrong. Yeah, I think I accidentally copied f of 8. Oh, did I screw up f of 8? Okay. F of 8 is twice f of 4... Or, sorry, 2k f of 4 minus... It's just k minus 2 times that thing. Or, no, 2k minus 2. I think f of 8 is okay? Oh wait, hang on. The k squared might be wrong. Yeah, f of 8 is 2k2. It says minus 2k squared. Oh! Oh, I see, yeah. Yes. Actually, I think it's missing in the current packet as well. I should fix that. Yeah, but it has to, right? Is the thing that... Yeah, it has to, because you know that k equals 1, 3, and 9 have to give you no additional information. Like, you have some identity k, and it has to be true when k equals 1, 3, 9. So, yeah, very beautifully, as everyone's saying, this factors. Screwed up by one. Okay.